The birth of the Tesla Model 2 begins long before its body is molded from liquid aluminum. It is born in the beating heart of a chip that Elon Musk nicknamed the Monster. The AI-5 is not just the car's computational center, but the symbol of a technological leap that redefines the limits of what is possible. While the automotive industry still debates how to achieve reliable autonomy, Tesla presents a chip with 8 times more processing power and 9 times more memory than its previous generation. This brutal combination of speed and capacity unlocks algorithms that previously choked on memory bottlenecks. The AI-5 removes the brakes from neural networks, allowing decisions previously made in hundredths of a second to now occur in almost biological time. The car stops reacting to stimuli and starts anticipating them. The future suddenly becomes tangible. Within this architecture, a silent revolution occurs by integrating hardware and software as if they were a single thinking entity. Tesla designs the chip and code together, avoiding waste, latency, and inefficiencies present in traditional systems. Unlike generic processors that need to adapt to hundreds of uses, the AI-5 exists for only one purpose: to drive better than any human being. This extreme specialization makes heavy operations, such as softmax and mixed precision calculations, flow with a lightness impossible in conventional architectures. Everything is built like a living organism, trained to see, understand, and act. The Model 2, therefore, becomes less of a car and more of an evolving cognitive entity. The video highlights that this monumental brain, capable of running complex models in real time, will equip a vehicle costing only $21,000. It's a conceptual shock. For the first time, cutting-edge technology blends with accessibility. Elon Musk's philosophy is simple. Revolutionary technology should not be a privilege, but the standard. The Model 2, instead of being a basic car, becomes the gateway for a generation that may be born without ever touching a steering wheel. Price is not a limiting factor, but a catalyst for mass adoption. Artificial intelligence, previously restricted to premium cars, descends to the level of the average consumer. And in doing so, it changes global expectations about what an affordable car should offer. This profound change reflects a new relationship between driver and machine. The AI-5 doesn't immediately transform the driver into a passenger, but rather into a supervisor. Human driving ceases to be the primary source of decisions and begins to act as a redundant safety system. The car assumes operational responsibility, making decisions based on data and algorithms trained on billions of kilometers driven by the entire Tesla fleet. Trust doesn't arise from promises, but from concrete results. Musk claims that the AI-5 is 40 times more efficient in critical tests, reducing errors and preventing accidents before they become real threats. A new paradigm is born. Driving ceases to be a necessity and becomes a choice. The video describes the AI-5 as a tireless co-pilot, incapable of distraction, anxiety, or sleep. This digital co-pilot observes its environment with a constancy that no human could match. All sensors, cameras, and radars work in sync, sending data at extremely high speeds thanks to a bandwidth 5 times greater than previous generations. This means that the car's perception is not a static photograph, but a living flow of information. By integrating these perceptions with continuously trained neural models, the vehicle develops a kind of enhanced situational awareness. It not only sees what is around it, but infers what might happen seconds later. And this anticipation saves lives. The video then moves on to another crucial element in the viability of the Model 2: the batteries. The biggest cost of an electric car is its energy pack, and reducing this cost is fundamental to democratizing the sector. Tesla is heavily betting on 2 emerging technologies: sodium-ion batteries and aluminum-ion batteries. The former offer a drastically lower cost, between $60 and $70 per kilowatt, precisely because they eliminate expensive and volatile metals like nickel and cobalt. In addition to being cheaper, they are thermally safer, reducing the risk of overheating and fires. Aluminum batteries, in turn, promise a revolutionary leap in density and charging speed. Both represent different paths to the same goal: making electric mobility cheaper without sacrificing performance. Sodium-ion batteries are noteworthy for their strategic simplicity. They rely on abundant, low-cost raw materials that are not susceptible to geopolitical interference. This characteristic drastically reduces the impact of global crises and fluctuations on the production chain. For an entry-level car, this means predictability, stability, and scalability. Tesla sees this chemistry as a robust solution for high-volume models. And although the energy density is lower compared to lithium, the combination with efficient aerodynamics and optimized motors compensates for much of this difference. The Model 2 can thus take advantage of cheap energy without losing competitive range. The real leap forward, however, may come from aluminum-ion batteries. These cells promise energy densities of up to 400 Wh, far surpassing traditional lithium batteries. Furthermore, they allow for ultra-fast charging, reaching 80% in just 10 minutes. This speed tends to eliminate one of consumers' biggest fears: refueling time. A battery that charges almost as fast as filling a gas tank completely changes the user experience. The result is a lighter, more efficient, and more affordable vehicle, combining high performance with reduced costs. For Tesla, this technology represents the key to overcoming barriers to widespread adoption. The video explains that if these batteries truly deliver on their promises, the total cost of the pack will drop to less than $5,000. This price reduction, combined with production line cutbacks, makes it plausible to sell the Model 2 for $21,000 while maintaining cutting-edge technology. Tesla demonstrates that affordability doesn't mean compromising innovation. Instead, it means rethinking everything, from materials to the manufacturing process. This strategy not only challenges direct competitors in the electric vehicle sector, but also traditional combustion engine vehicles. It's an economic, technological, and cultural disruption designed to transform the global market. While many manufacturers still treat electric vehicles as a niche market, Tesla is targeting the heart of the mass-market car segment. The video highlights that the Model 2 doesn't just compete with rival electric models. It directly challenges cars like the Toyota Corolla and Honda Civic, icons of combustion engines. Equipped with fast charging, competitive range, and a price similar to traditional vehicles, the Model 2 proposes a definitive switch between combustion and electricity. The argument ceases to be environmental or futuristic and becomes purely rational. Why buy a car that requires expensive maintenance and increasingly volatile fuels when an electric car offers cheap operation and superior technology? Tesla's strategy goes beyond embedded technology. It also transforms the manufacturing process. The company doesn't just want to produce the Model 2. It wants to reinvent how cars are produced. The gigacasting technique reduces hundreds of components into a few giant blocks of molded aluminum. In a single piece, it replaces welds, robots, parts, and entire assembly steps of traditional manufacturing. This reduces time, errors, and costs. In the rear chassis, for example, more than 400 parts were eliminated. This brutal simplification allows Tesla to increase the pace of production and reduce the final price for the consumer. The advantage of gigacasting is not only technical, but strategic. By reducing complexity, production becomes faster and easier to scale. The assembly time for a car that would normally take about 30 hours drops to less than 15. This means Tesla can double production without doubling the size of the factory. Every square meter of the assembly line becomes more efficient. This operational gain allows for greater investment in research, automation, and innovation, creating a virtuous cycle. With the Model 2, Tesla aims to make production as advanced as the product itself. The location of production plays a crucial role in this new phase. The Gigafactory in Mexico emerges as a central piece of Tesla's global strategy. With labor costs at $5 an hour, logistics costs 20% lower than in China, and direct proximity to the United States, this factory has the potential to become the company's largest in terms of volume. Furthermore, it opens doors to European tax incentives that favor electric vehicles produced outside of Asia. These incentives can include subsidies between $4,000 and $6,000, making the Model 2 even more competitive against established brands like Volkswagen and Renault. Tesla is capitalizing on an inevitable trend. While other companies are fragmenting their global lines, Tesla is integrating production, logistics, and technology into a single architecture. The Mexican factory will utilize advanced automation, AI and process management, and extreme modularity, allowing different models to share components and assembly stages. This reduces costs, speeds up changeovers, and enables rapid adaptations to meet local demands. In a traditionally rigid industry, this level of flexibility represents a decisive competitive advantage. Tesla doesn't just make cars, it makes factories capable of evolving. Elon Musk has set ambitious goals to reach 1.5 million units produced per year by 2027. This number surpasses the historical sales peak of the Volkswagen Golf, the best-selling car in Europe for decades. This scale is not just ambition, it's a necessity. Tesla's mission has always been to transform mass mobility, and the Model 2 represents a turning point in this. Through process-centric design, the car is shaped to fit the factory, not the other way around. This reversal of logic drastically reduces complexity, enabling volumes that would previously have been unfeasible. The Model 2 doesn't just want to be cheap, it wants to be desirable. The design is minimalist, elegant, and intentionally familiar. Tesla adapts its traditional clean style to meet the needs of dense urban markets, especially Europe and Asia, where narrow streets demand compact and agile cars. At 1.8 meters wide, the Model 2 offers a perfect balance between practicality and comfort. Its competitive positioning puts it directly against leading vehicles like the Volkswagen ID.3 and Toyota Yaris, but with a much greater technological appeal. In a market saturated with generic compacts, the Model 2 stands out for its futuristic purpose. Aerodynamic efficiency is one of the model's secret weapons, the drag coefficient below 0.23 is extraordinary for its segment, guaranteeing greater range and better energy efficiency, even with smaller batteries. The less air resistance, the less energy is consumed to maintain speed, extending the range on urban and highway routes. The hatchback design maximizes interior space while maintaining a compact exterior. Every curve, every surface, and every detail is shaped to unite aesthetics and functionality. The result is a beautiful, efficient car adapted to the real world. Inside, the video depicts a functional, minimalist, and digitally connected environment. A single touchscreen controls virtually all functions, reducing buttons, costs, and points of failure. The system integrates high-quality sound, 5G connectivity, and access to entertainment, navigation, and updates via the cloud. This approach eliminates the need for frequent maintenance and ensures the car improves over time. Minimalism is not the absence of features, but the presence of simplicity. Everything in the Model 2's interior is designed to be practical, durable, and intuitive. Even as an entry-level model, the Model 2 will have versions equipped with AI5, unlocking the full self-driving function. This is unprecedented for this price category. Autonomy ceases to be a luxury and becomes a fundamental feature of an affordable car. With this technology, the vehicle will be able to navigate complex urban environments, busy highways, and unpredictable scenarios with increasing ease. Each over-the-air update improves the system, ensuring continuous evolution. What seems extraordinary today will become the new normal tomorrow. Democratized access to autonomy can redefine the very idea of driving. Rumors indicate that Tesla is considering a retractable steering wheel and gesture controls for advanced versions of the Model 2. This possibility hints at an even bolder vision, an interior designed for conviviality rather than control. The car becomes a living room, office, cinema, a mobility capsule. The interface ceases to revolve around the steering wheel and begins to revolve around the user. If confirmed, these features will transform the Model 2 into a design laboratory that will influence future models of the brand. Tesla is preparing the ground for a new automotive language, where driving is not the central function, but merely an option. As the video progresses, it becomes clear that the Model 2 doesn't want to compete, it wants to replace. Its design elements, its embedded intelligence, and its aerodynamic efficiency are not increments. They are paradigm shifts. It aims to make traditional city cars obsolete, offering a superior alternative in virtually every aspect. The European market, for example, demands compact, economical, and agile cars, precisely the territory where the Model 2 shines. In the United States, its low cost and competitive range make it an irresistible option. In Asia, its connectivity and urban agility set it apart in dense, technologically advanced cities. It's a global product with global ambitions. The video suggests that the Model 2 represents Tesla's ultimate effort in redesigning the concept of an affordable car. It combines low price, high technology, innovative production, and modern aesthetics in a seemingly impossible package. The combination of advanced AI, gigacasting, new battery chemistries, and factory automation presents a vision of the future where electric cars cease to be an alternative and become the standard. This cultural shift has a direct impact on the energy and automotive industries, pushing the world away from combustion engines. What Tesla offers with the Model 2 is more than a vehicle. It's a historic transitional experience. As we approach the halfway point of this analysis, the narrative makes it clear that the automotive universe is about to undergo a disruption similar to the migration from basic cell phones to smartphones. The Model 2 takes on the role of catalyst for this transformation. It offers not only mobility, but continuous connectivity, adaptive intelligence, and constant evolution. Buying this car is not just acquiring a means of transportation, it's buying software on wheels, an intelligent organism that improves over time. In this transition, the price range ceases to be a barrier and becomes a symbol of cultural change. Cutting-edge technology finally reaches the average citizen. What's most impressive about the video is realizing that these innovations aren't distant dreams, but real components in advanced development. The AI-5 exists, it's being tested, and its performance impresses engineers and specialists around the world. Sodium-aluminum batteries are advancing rapidly and already demonstrating viability. The factory in Mexico is beginning to take physical shape. Production targets are aggressive but coherent. Tesla isn't promising the impossible. It's executing a meticulously planned strategy. This execution transforms speculation into real impact, and real impact into global change. At the heart of this revolution is the philosophy that the car of the future shouldn't be more expensive, it should be smarter. The video reinforces that Tesla wants to break the traditional logic that allowed automakers to charge more for each small technological upgrade. Instead, it wants to reverse this equation, offer more for less, democratizing access to advanced technology. The Model 2 is the symbol of this reversal. It proves that it's possible to deliver autonomy, efficiency, aesthetics, and performance in an affordable package, something that was previously considered utopian. This disruption redefines expectations for the entire industry. Every element of the Model 2 seems designed to solve a historical problem for urban cars. The compact size for cramped cities, the aerodynamics for energy efficiency, the battery for cost reduction, the AI-5 for safety and range, production for scalability. By combining these factors, Tesla creates a product that meets the real needs of real users in real countries. It's future-oriented engineering, but grounded in practicality. The Model 2 isn't a car born to impress, it's born to dominate. And when these characteristics converge, a new automotive era approaches. The first half of the narrative shows that the Model 2 is much more than a launch. It's a statement. It expresses the vision that the modern automobile should not be complex, expensive, or limited. It should be efficient, accessible, and intelligent. The video highlights that we are facing a profound structural change where cutting-edge technology ceases to be exclusive and becomes a tool to promote global inclusion and efficiency. The Model 2 is not just another electric vehicle. It is the beginning of an ecosystem where mobility, AI, and mass production converge to shape the future. The second half of this analysis delves into the structural impact the Model 2 will have on the global automotive market, highlighting that its role goes far beyond technological innovation. It acts as a driver of economic change, pressuring entire industries to revise their business models. The introduction of such an advanced electric vehicle for $21,000 forces competitors to reconsider strategies, costs, and timelines. By making current paradigms obsolete, the Model 2 initiates a race where efficiency, range, and affordability are more important than luxury or tradition. Tesla redefines the game and forces everyone to adapt or be left behind. With the AI-5 chip embedded, the car operates as a cognitive entity within urban traffic, transforming mobility into something predictable and safe. The chip's intelligence allows for levels of precision previously unimaginable in entry-level vehicles. With every kilometer driven, it collects data, processes events, and learns from unprecedented situations, continuously improving. This distributed learning, fed by the entire Tesla fleet, creates an accelerated evolution cycle. For the user, this means that the car bought today will be smarter tomorrow. This continuous promise of progress reinforces the perception of value and places the Model 2 in a category of its own. The combination of advanced AI and affordability profoundly alters consumer behavior. Many drivers who never considered owning an electric car will now consider making the leap directly to an autonomous vehicle. The idea of delegating driving to an intelligent system becomes more familiar, especially when compared to human limitations. Fatigue disappears, anxiety behind the wheel decreases, and daily commutes gain a new dynamic. The Model 2 offers a natural transition to a future where driving will be a choice, not an obligation. The cultural shift is as profound as the technological one. From an energy standpoint, new battery chemistries introduce a completely different logic to the refueling of electric vehicles. The use of sodium, an abundant and inexpensive element, reduces dependence on unstable supply chains and increases the sector's collective security. The possibility of ultra-fast charging with aluminum batteries eliminates one of the main arguments used against EVs: the time lost refueling. This new reality makes the electric car more competitive than the combustion engine vehicle.